Hello, everyone. Good morning, good afternoon, good evening. Thank you for joining us today. We are here to talk about AI agents and not just talk about them, but we actually want to get hands on and build them. And we all know that as we are building our agentic architecture, Model Context Protocol or MCP has become a core element. In just a few months, we have seen how MCP is helping standardize agents to tool communication. And here at Snowflake, we have been innovating in the AI space every day, not only to keep up with with the industry, but to lead it from the front. So in this lab, we'll be building agents, we'll be setting up MCP. We will have the one and only Josh Reini with us, who will be running the lab. We'll make it fun, we'll make it interactive, and we'll make it worth your time. So let's jump in. Just a quick reminder to make all of your purchasing decisions with available information that's public, such as our website. The first thing I want to say is, we all know that data lives across multiple platforms, right? When we are talking about enterprise ecosystem, we may have our data in Snowflake for structured and unstructured data. Maybe my code lives in GitHub. Maybe the docs are on Google Drive or SharePoint. Data is really spread across my entire ecosystem. And we know that our AI agents need the right data at the right time to be useful and get that right answer to the user. So the question is, how do we connect agents with all of my data in an efficient and easy way? And this is where MCP comes in. MCP is an open standard protocol that allows agents and external systems to communicate, to discover and invoke these tools that are used for these agentic flows. So MCP helps us deploy agents faster. It can connect to more systems and make sure we are governed consistently across the entire enterprise. But the question is, how does this protocol and structure help with the application architecture? So if you think about the application architecture, normally I would have to maintain an integration for each of the platforms that I have in my enterprise, right? For Google Drive, for Stack, for GitHub, we'll need to do this for every single agent. So the complexity is of the order of you have n agents connecting with each of my m platforms or data sources, resulting in a n by m connectors. And that's really complicated. If you think about how MCP helps with this problem, is really MCP simplifies the application architecture and it removes the need for these custom integrations. With MCP, you now have a n agent connecting to your m platforms or data sources with one single protocol, right? It's standardized. Or in this case, it becomes a n plus m connection versus a n times m connections. And therefore, it's really an architecture which is an order of magnitude simpler. And this is why MCP is helping developers build enterprise applications super fast and go from our data to insights very quickly and reliably. So let's take a look at how Snowflake is creating, the same level of flow, how Snowflake is helping developers with our latest innovation, which is the Snowflake managed MCP server. So if you look at our innovation, so MCP server for Snowflake is built on a host client server architecture, exactly what you would expect for an MCP architecture. The hosts are AI applications such as Claude Desktop, where you run your agents. The clients are components inside those hosts that maintain connections to the servers. And really, the servers, in this case, the Snowflake MCP server or the Snowflake managed MCP server, it surfaces tools and resources for the agents to use. And all of this in the context of the most critical part, which is, we know that agents need the right context from your data to be accurate and enterprise ready. And Snowflake MCP server provides context to your agents. Specifically, when you see what's going on here under the hood, is the Snowflake MCP server includes Cortex Analyst and Cortex Search as tools. So Cortex Analyst translates your natural language request into SQL, and it runs this SQL and generates an answer to give you insights from your structured data. On the other hand, Cortex Search covers the 80% of the unstructured data. This is a hybrid search, and it enables semantic search and retrieval from your unstructured documents that are stored or indexed by Snowflake. What happens is users can also retrieve data from other sources, such as Cortex Knowledge Extension, which is a way to get data from licensed content from top publishers such as Associated Press or the Washington Post. So you can use all of those to retrieve the data that is needed for the agents. And in the future, we will also be supporting Cortex agents in the MCP server. So we are building towards that, and it should be available soon so that remote applications can invoke these agents as tools. And you will see all of this in the lab today. So when Josh gets started, You will see how we can bring all of these tools together. How do we stitch them together using MCP? And how do we get this entire architecture? So, without any further ado, let's get hands on and let's welcome Josh to help us run the lab. Over to you, Josh.
My name is Josh. I'm a developer advocate here at Snowflake, and I'm excited to work with you to build this agent. In today's hands-on lab, we'll be building a health research agent. This health research agent will be designed for medical researchers and healthcare professionals that need instant access to both medical research from PubMed and clinical trials data from clinicaltrials.gov. We'll gain access to these data sources through the Snowflake Marketplace, specifically as Cortex Knowledge Extensions. These Cortex Knowledge Extensions are ready-to-use search services or retrievers that we can pull into our Snowflake account, and then we'll expose them as tools to our agent through MCP servers. Once we've done that, we'll build our agent using LangGraph and connect to these tools. Then we'll evaluate how well our agent is using these tools and make sure that it's performing and ready to go. Let's get building. So as a refresher, the steps to add MCP to your agent, the first thing you need to do is to get AI-ready data. This could be from the Snowflake Marketplace, like we'll do in this hands-on lab, or data that's in your Snowflake account already. Then you want to create MCP servers for this data, connecting to search services, analysts, and eventually agents. You want to set up authentication. This could be OAuth, which is supported in our managed MCP server, or PAT, as we'll do in the hands-on lab today. And then last, you'll connect your agent, the MCP client, to the MCP server. Then we're ready to go. So to get started with the lab, you're going to start by signing up for a Snowflake account. You can do that by going to signup.snowflake.com or scanning this QR code. I'll give you a few seconds to do that. Once you've signed up for your Snowflake account and logged in, I'll meet you in Snowflake. You've logged in to your brand new Snowflake account. For this lab, this is how we're going to connect our agent to data. Specifically, we want to get data from the Snowflake Marketplace, and we'll use two Cortex Knowledge Extensions. This is a fancy way of saying that Cortex Search services that are pre-created for you and living in the Snowflake Marketplace. That means that the underlying data is already chunked up and indexed, so you can just search on it. Now let's go to the Snowflake Marketplace and find the first one. We'll go to the search bar and search clinical trials. Then we want to scroll down and choose the clinical trials research database. That's free and instantly accessible. Once we choose it, we can choose Get. And we want to choose this dropdown and give it access additionally via the public role. That way, we can use the public role to query this knowledge extension. Then we can choose Get. Now let's find our second data set. We'll search PubMed, P-U-B-M-E-D, in the search bar, and choose the PubMed Biomedical Research Corpus. Then we'll choose Get at the top, again, adding the public role access to the knowledge extension. Awesome. It was that easy to add these retrievers into our Snowflake account. Now, once we create our agent, we'll be able to use these tools to search both over the PubMed Biomedical Research Corpus, along with all the data from clinicaltrials.gov. So you don't have to worry about all of the pre-processing and indexing that you would normally have to do when you're creating a search service. If you want to learn more about these data sets, you can also scroll down and read a bunch of great information about how to use this data directly stored in the in the Snowflake Marketplace listing. So now that we've gotten our AI-ready data and our search services loaded into our account and ready to use, the next thing we want to do is create our MCP server. So to create our MCP server, we want to go back to the GitHub repository and copy the code that we need. So to get access to the code, you'll want to go to this bit.ly link right here. This link will give you direct access to the GitHub repository we'll be using for the rest of the lab. I'll give you a few seconds to get onto that repository. So let's go back to the GitHub repository and then open up create MCP server.sql and copy this code. Then we'll go back to our Snowflake account and we're going to choose projects and then workspaces. And we can open up a new worksheet by choosing the plus tab on the top and paste in the code to create our MCP server. So here, let's walk through the code. We're going to create a new database called HealthDB, and then we're going to use that database. Then we're going to use this public schema to land our MCP server. The last thing we want to do is create or replace the MCP server from this specification. In the specification, we're going to list two tools. In each tool, we'll include a name, an identifier, a type, and a description. The name is whatever we want to call this particular tool. And then the description is going to describe this tool. The combination of the name and the description is how the agent is going to choose which tool to use when. So these are really important that we make clear to the agent. The identifier here is exactly where in your Snowflake account the tool lives. In this case, it's the search service. And the search service from the Cortex Analyst extension is always going to be on this exact database schema and search service name. The last thing that we want to include here is the type. So here we're both using Cortex Search services as our tools. So we want to set the search service type right there. And then the last piece of this code, once we've created the MCP server, is that we want to grant usage on the MCP server to the public role. So that means that the public role is going to be able to access and use this MCP object. Let's choose run all. Now we've created our MCP server. So in the next step, when we go create our agents, we're going to be able to use the MCP object for the agent to be able to connect to tools.
I mean, this is fantastic, Josh. Really exciting stuff. But I do wonder, since we are building something for enterprises, once your MCP server is created, how do I make sure that my data is only accessible to the right user? I mean, it's really important to make sure, I'm not exposing my data. Everything is safe and secure. So, and I know there's a lot of conversation around this topic. So, would love to get your thoughts on it.
Yeah, that's a really good question, Arun. So let me jump and show you to kind of explain this in a slide. So first, the managed MCP servers support both the OAuth authentication and the PAT authentication like we're doing in the lab. And then once you're actually connecting and using the MCP servers, there's three really important parts you want to know about access control. So the first is that to use the MCP servers, you need usage on the MCP object itself. So this is what you need to both connect to the server and discover which tools are available. Then when you go to invoke the tools, so actually calling Cortex Search or calling Cortex Analyst through the MCP server, you need usage on those underlying tools so that any roles that have access to particular domains or departments in your company, they need access to the right search services. So you can only actually invoke the tools that you have access to through your role. And then last is that you're going to need usage on the data as well. So you need to not only be able to call the search service, but you actually need to be able to view the underlying data. So you're going to need to set up all of three of these pieces to ensure that access and control is well set up and well governed for your use case. So the second setup step we need to do as we're getting started is we need to alter two account settings. So we're going to go to alter account settings.sql in that GitHub repository, and again, copy the code. And then let's open up a new SQL worksheet and paste it. And then we'll again run all. So we're altering two specific settings here for our account. The first is that we're enabling cross-region inference so that we can access Claude Sonnet 4.5. This is a really powerful LLM from Anthropic that we want to use in the lab. The second setting we're setting up is that we're creating a network policy. This is a very permissive policy we're creating in this trial account for the lab. And in reality, you'd want a much more restrictive policy set up for your company and business. But this is going to simply allow us to call and use our access token from our external agent. Awesome. Let's get back into the code. So now that we've run both of the SQL scripts that we need, we can open the notebook. This is going to be the IPy notebook file that's in the repository. So as you're opening the notebook, the first thing you'll want to do is to fill in your keys. For the purpose of the recording, I've already ran and filled in my keys here, but you're going to want to fill in your keys as well. I'll notice that in addition to the Snowflake credentials here, we're also using an OpenAI key. That's because you're building an external agent, so we really want to show you what the flow is for adding the Snowflake MCP server as tools into your external agent. So you're going to want to fill in all of these credentials here, bringing your own OpenAI key. Then the next thing we'll do is create our Snowpark session. This is how we're going to connect to Snowflake using the account, the path, along with the database and schema of our MCP server. Now that we've set up our connection to Snowflake, we can start to work with LangGraph. LangGraph is going to be our agent building framework. And the first thing we need to do is create our MCP client and connect it to the MCP server in Snowflake. So to do that, we're going to use this multi-server MCP client class from LangChain, specifically the LangChain MCP adapters. And then we're going to pass in the name of the URL for our Snowflake MCP server that we set at the top. And then we're also going to pass in our PAT as an authorization bearer token. Once this cell runs, now we have our tools ready to go to add to our agent. For our agent, we're also going to use GPT-4o as our LLM. And now we can get started building the agent. We'll define a simple call model function that's going to call our LLMs with the tools binded to it. These tools being our MCP server tools to search PubMed and to search clinical trials. And then we'll build our graph. This is a very simple agent graph. It only has two nodes, calling the LLM and using the tools. Our agent will always start with calling the model. And then as it finds or needs access to call tools or make more LLM calls, it can do so using this conditional edge. We'll compile the graph, and then we'll wrap it in a simple Python class to make it synchronous. Now, we built our agent, and we can try it out. We can try it out by asking a simple question like, what is the primary indicator for a specific drug? What this agent is doing is calling the LLM to answer the question, and then the LLM, if it decides it's necessary, will then reach out to our MCP server to get access to search results from either clinical trials data or PubMed. And we see it's done exactly that. When we invoke our agent, you see both AI messages and tool messages. Tool messages being an indicator that it actually used the MCP server. And then last, we see the final answer, where it's actually synthesizing that data that it got from Snowflake to give you the nice human readable answer right here. Awesome. So we see our agent is working, but how do we know how well it's performing? This is where AI observability and evaluations come in. So to get started with evaluations, we first want to initialize our TrueLens session. This is how we connect to Snowflake so we can store our logs, traces, and evaluations as we're evaluating our agent. To make this connection, we're going to simply import the Snowflake connector and then pass in the Snowpart session that we created earlier. Then we need to set up our evaluations. We're going to use Claude Sonnet 4.5 to evaluate our agent. And we're going to use two metrics in particular. One, tool selection, which will evaluate if the agent is choosing the right tool at the right time. And then the second is tool calling, to make sure when the agent is using a tool, it's using it correctly. It's passing the right parameters and the right query.
This is great, but I would love to know how these evals are set up, and what they're actually doing to measure the performance of the agent. I know it's really important for the builders and the developers to feel confident about the agents and how they're performing. I would love to just go a little bit deeper if you can.
So these metrics are set up as an LM judge. What that means is that we've gathered a very specific prompt with criteria on things to evaluate. And then we're passing that along with data about how the agent is actually executing to an LLM. And that LLM is going to use data from the agent's trace or data from exactly describing how the agent performed. And then combined with the criteria on how it's supposed to think about performing well versus performing poorly, it's going to use that to produce a score. This score is going to tell us whether the agent is performing well or performing poorly on these very specific criteria. So to kind of punch that up a little bit more, we're using two metrics here, tool selection and tool calling. So for tool selection, we've created a very specific set of criteria that describes exactly what it looks like for an agent to select the right tool versus select the wrong tool. Then we're passing in the entire execution trace of exactly what the agent is doing. By passing all of this data in to the LM judge, then the LM has access to see every step of the way as the agent is executing. So as the agent is selecting each tool, the LM judge can see exactly what information it had ahead of time when it was making that tool selection decision. Then the LM judge is taking all of that data and comparing it to the criteria to make that final call. Is the agent choosing the right tool or not? So that's the tool selection. The second is the tool calling. Very similar. We're still taking all of the execution trace and passing it to that LM judge. And then now the LM judge is looking at something slightly different. The LM judge now is going to look at to see if the agent is passing the right parameters to the right tool. It's going to notice if the agent is running into issues or using parameters that aren't available for that tool. This is really important when we want to make sure the agent is actually using the tools effectively. So we've defined our two metrics. And then the last thing I want to point out here is that we're using this metric config object. So this metric config is how we're going to define custom metrics that are going to be computed and added to Snowflake AI observability. What this means is that we're going to manage the computation of these metrics in the client or on our local device. Even though we're calling LLMs, in this case in Snowflake, to actually do the evaluation, we're kind of managing the compute and the computation of these metrics locally, and then once they're done, ingesting that final evaluation result back into Snowflake. This allows us a lot of flexibility. So rather than using the smaller set of predefined metrics that are available and can be managed all the way in the Snowflake on the server side, here we're using client-side metrics, and we can ingest them to Snowflake. So that means we can use any metric we want to evaluate exactly how well our agent is performing. And this allows us to get super custom and super domain specific. This is really nice when you're building and evaluating agents, because agents can often operate in really super agents can operate in really specific domains. And you often want to design your evaluation metrics specific to the domain that they're operating. Then we can register the first version of our agent. We'll register it using TrueGraph because we're using LangGraph as our agent building framework. Using TrueGraph allows us to capture specific LangGraph specific calls so that we can see a detailed view of exactly what LangGraph is doing under the hood. We'll pass in our agent object along with an application name and a version. And then we'll set the main method of the agent. This is the same agent.invoke we used a bit earlier to call the agent. And then we'll connect it to Snowflake. Then we need to create our data set. This is the test set that we're going to use to make sure our agent is working well. Here I'm using a relatively small test set of just 3 queries. And in reality, you might want to use a bigger test set that mirrors what you might see in production. To set up our data set to evaluate, we want to create what's called a run. A run is a fancy way of saying that this is the data set we want to use to evaluate our agent. We're going to add this data set as a run config, just like this. Then we'll choose run.start to execute a batch run. What this means is that we're invoking our agent against each query in our data set individually, and then we're going to log all of the traces to Snowflake. Once we've done that, we can see exactly how the agent is executing. We can see all of the intermediate steps the agent is taking along the way to getting its answer. This invocation may take some time as it's executing each of the 3 queries, so we can give it a few seconds to finish.
So while it's running, tell us a little bit more, like what have we done so far? Just give us like where we were, what happened, what we are doing, and what we'll do next.
So we've already built our agent. We've connected the agent to the MCP server in Snowflake so that when the agent executes, it can call tools and get data that it needs to answer the questions and complete the tasks it's given. Then we've created the data set that we're going to use to test our agent. And we've registered our first version of the agent to Snowflake. So when I say we've registered it, what this means is that I've captured some metadata around this particular version of the agent so that when I measure its performance, I can tie it exactly to this code. Then later, if we iterate or improve the agent, then I can compare exactly how well it's performing now to how well it's performing in the past or the future. Does that make sense?
Yes, absolutely. Yeah, that really makes me feel like I have the comprehensive view of the agent and what it's doing in the current code. So that's great. Thank you.
So the last thing we want to do to evaluate our agent is we just want to compute some metrics. So we've already logged the traces of exactly what our agent is doing. And now we're going to take that trace data and compute the metrics on it. So to do this, we'll just run.compute metrics and pass in that list of metrics that we set up earlier. So that's the tool selection metric and the tool calling metric. So to save a bit of time, I've already computed the metrics for us ahead of time. So we can jump in straight to Snowflake to exactly see what's going on here with our first run of the agent. So now I've opened up the AI Observability tab, which you can find on the left side of the screen by clicking Evaluations. And I've clicked on the application name that I set up, the Healthcare Research Agent. And once I've done this, you see each of the 3 queries that was in our dataset. You'll see some durations on how long the agent took to complete each query. And you'll also see some evaluation metrics for tool calling and tool selection. In particular, you see some red scores here, indicating that the agent isn't performing very well in some cases on both tool selection and tool calling. So let's dig in a little deeper and click on to see exactly what's going wrong. Let's start with this bottom row. What is the primary indicator for the drug Xeljanz? And as we open this trace, the first thing I notice when I'm looking at the left here is that there's no tool calls. It's not actually reaching out to the MCP server. And if I open up the tool selection evaluation and kind of read what I have in the supporting evidence here, what we see is that there's a few critical issues. In particular, that the agent is missing the opportunity to use the tool. It's actually not selecting any tool at all, when in fact, the tools would be clearly beneficial. And this is a big problem with our agent. We need the agent to be grounded in real data from these tools instead of using the LLM's internal knowledge to answer the question. So that's a big thing we want to improve on the tool selection side. Let's go to the next query. So in the second query, you see we are calling a number of tools. You see clinical trial search a number of times in the trace. But one issue you do see is that the response seems to have failed to actually access that data. And if we open up the tool calling evaluation, we see that the agent is repeatedly calling these tools, but it's running into issues knowing which parameters are available to actually search. This is also a big problem. When we access and call these tools, we want to call them correctly the first time and know exactly which parameters to use. These are improvements that we need to make in the tool descriptions in our MCP server. So to iterate and improve your tool descriptions in the MCP server, we're going to redefine the MCP server that we created earlier in the lab and see if we can improve those tool descriptions to better both select tools and use them once we've selected them. Let's give that a try. So to do that, you're going to go back to the GitHub repository over here, and then you're going to create MCP server v2. So here I've already updated the descriptions for each of these tools to solve some of these issues. I've made updates to tell it that it should use these tools in specific use cases. So I'm mapping specific use cases and saying these tools are mandatory use in those cases. And then the other update is that I've told it exactly which parameters to use, that it should only provide the query parameter with the search terms rather than guessing on which columns or parameters might be available in the search service. Let's copy this code again and then go back to our Snowflake account and create this new version of the MCP server and then reevaluate our agent to see if we can use the tools better now that we've improved the tool descriptions. So to do this, we're going to want to go back into Snowflake into our worksheets tab and create a new worksheet. and then again, paste the code. So I'm just going to create a new version of my MCP server with a v2 tag on the end of the name and choose run all. And a slight update to the syntax here. And there we go. So I've created my new MCP server with these updated tool descriptions. Now let's go back to our notebook and give it a try by retesting our agent on the exact same test set. So our setup for our second version of the agent is going to look almost identical to what we did the first time. We're connecting our MCP client, the agent, to the MCP server using this LangGraph class, multi-server MCP client. And the only thing is that we're just changing the URL that we're connecting to, connecting now to this v2 version of the MCP server. Then we're going to just rebuild our graph exactly like we did the first time. And we're going to re-register the new version of our agent, again calling TrueGraph. But the important point to call out here is that I've changed the application version so that we're going to be able to compare this new version of the agent with the old. And then I'm going to recreate my run and add it to this new version of the agent. So again, my run is that data set that I want to use to test how well my agent is performing. And then once this agent finishes executing on each of these queries, I'm going to want to again compute metrics to see how well it's doing. So again, saved some time. I've already finished the invocation of the second version of my agent and computed metrics. So we can jump back over to Snowflake to see how well this. We can jump back over to Snowflake to see how well this second version of the agent is performing. So now I'm back on the AI observability page. Again, you can access this on the left pane by choosing the AI and ML little icon and then evaluations and choosing the healthcare research assistant application name. Now you see two versions of the agent. Our first version, base, on the bottom, and our second version, v2 improved descriptions, on the top. And the headline metrics are really positive. We see tool calling has jumped from 0.56 to 1.0, and same for tool selection. To dig even deeper, we can select each of these application version names and choose compare to see these head to head. We see the metrics on the left with the first version of our agent and on the right with the second version of our agent. And we could even click on a query to see exactly how the trace differs between these two versions. So let's click on this first one, where in the first version of our agent, the agent was failing to make tool calls at all. So on this left side of the screen, we see that first version of the agent. The agent execution trace is super short, and there's no real tool calls here. So the agent is acting in an ungrounded way. It doesn't have data from Snowflake that it needs to answer the question, and instead it's using the LLM's internal knowledge. On the right side, with the improved tool descriptions, the agent now has the knowledge it needs from that tool use to answer the questions. It's making calls to both PubMed and clinical trial search to answer the question. And we see this reinforced in the improved metric scores here, along with the LM reasons on exactly why this agent scored the way it did. Now that we've run through the demo and improved our agent's effectiveness to use tools and answer questions, let's go back to build this into some takeaways that you can really use when you're building your own agents. So we saw some common errors for tool calling. We often see issues with tool selection where the LM uses internal knowledge instead of tools when it should. And we can even sometimes see issues where the agent selects the wrong tool. With tool calling, as we saw in the lab, we can have issues where the wrong parameters are passed to the tool, and this can result in failures or just imprecise uses of the tool. And we can even see times where the agent uses the wrong query for the tool. To generalize these into some improvements that you can make when you're writing your tool descriptions, you should focus on mapping key use cases of your agent to specific tools. This is exactly what we did when we rewrote those tool descriptions. You also want to provide instructions both when to use and when not to use each tool. And you want to be really explicit about which parameters are available for each tool. This is another pattern we implemented in that version 2 of our tool descriptions. And by doing that, we saw a huge jump in the performance of our agent. Now, our agent was able to effectively use and call tools, and we saw this reflected in the evaluation metrics. Thank you so much for joining the lab. It was a lot of fun to build our agent. Let's recap what we did. So the first thing we did is we connected and loaded our AI-ready data from the Snowflake Marketplace. Specifically, this means that we pulled in data from PubMed and the clinical trial search. And these were both pre-built retrievers as Cortex knowledge extensions. And this means that these search services are already configured. The data is already chunked up, and they're ready to use and add as tools to our agent. Once we had our data ready to go and our search services set up, then we created our MCP server. This MCP server is how we actually connected our external agent to those tools. We used LangGraph to set up our agent, and a very simple graph allowed the LLM to call these different tools and had the autonomy to decide when to use which tool. Once we built our agent, we tried it out. We asked a couple test questions, but to really understand how well it was performing, we used evaluations to systematically measure the agent's performance. To use evaluations, we connected TrueLens and Snowflake, specifically Snowflake's AI observability. We registered the first version of our agent with an application name and an application version, so we can actually track the metadata and compare different versions of our agent. We created a test set that will mirror exactly what our agent will be exposed to in production. And then we ran our agent against every query in our test set. That way we can actually watch how well the agent's performing on these different queries. Once we've observed and logged all of that data from the agent's trace, then we computed some metrics. We computed tool selection and tool calling evaluations on that trace data so we could see exactly how well the agent is choosing which tool to use and when, and how well it's actually calling the tool itself. These are super important when we're starting to add tools to our agent, because we really want to make sure that the agent is using the tools effectively and that we're not just blindly exposing tools that the agent doesn't know how to use. Tool use is also super critical for agents because it's actually what allows the agent to ground its answers in real data. So a lot like the RAG paradigm, where we use search and retrievers to give the agent the knowledge it needs to answer questions, you can think about these tools in a very similar way. So by doing these evaluations, we could actually make sure that the agent is using these tools effectively. And we noticed in our first version that the agent wasn't doing that. The agent was choosing the wrong tool or even not choosing to use a tool at all in some cases when it should have. And it was not always using the right parameters that it needed to when calling these tools. This resulted in both inefficiencies and ungrounded answers in the tool, and we saw that in the evaluation results. Then we went back to our MCP server definition, our MCP server spec, and updated those tool descriptions so that we could improve on those two specific axes, tool selection and tool calling. We mapped very specific use cases on when specific tools should be used and set those as mandatory in the tool description. And then we also described exactly which parameters were available for which tool. By making both of these updates, the agent was then able to effectively use the tools that had available, and we saw this reflected in the evaluation results. We were able to validate that the agent was performing better. This mirrors a very typical setup as you're starting to set up your agent. You want to first build the first prototype of your agent, connect the tools. You want to measure its performance with evals, and then hill climb on those metrics. And once your agent's performing really well in your test set, then you can feel confident to move it into production. So to wrap up, our agent is able to use the MCP servers on Snowflake, which are governed by design, really easy to connect to your agent, and gives you secure access to all of your data. And additionally, gives you room to refine your usage of these tools. Thank you so much again for attending the Hands-On Lab. There's a lot of fun stuff in the works and a lot of great content for you to enjoy. Thanks again.